Our customer builds metal carts that are used to provide storage and access to various medical supplies that are used primarily in nursing and assisted living facilities. Our new emergency medication cart looks similar, but you'll see throughout this review of the product that it is much more than just a metal storage cart. Once a drawer is opened, a system of storage containers for accessing drugs and medication is revealed, and I will explain the product we developed for our customer. I will break this complex system down into the basic building blocks that make up each of the assemblies and explain how controls are in the system to provide only secure access to the drugs as they move from a security-controlled pharmacy environment until they are finally administered to the correct patient, which includes a complete record of each transaction for both security and invoicing purposes. The first and most basic piece is the container that holds the drug or medication. It is a symmetrical design so that only when removing the pills from the box does it make a difference which side is up or the top of the plastic box. There is a collar around the top that holds a tamper-evident label. Once the pharmacy attaches the label onto the small pill container, it cannot be removed without tearing or showing evidence that the label has been removed to access the drugs inside the pill box. Each symmetrical pill box is locked in position until released by the system software. Then, when it is returned to the open position, which is identified with an LED, there is a sensing microswitch and locking solenoid mechanism that relocks the box in position. That same mechanism prevents the box from entering an incorrect position. The next piece of our assembly is a module. The module is a completely standalone and field replaceable piece of the entire system. The module holds 10 standard size pill containers, and there is an oversized pill container that takes up 2 spaces in the module. It consists of individual sensing and locking mechanisms for each pill container, and a microprocessor that controls the instruction set that comes from the system software through the onboard CPU. Starting at the CPU with its touchscreen input, an interface board controls the entire system. From the CPU, through the interface board, the module, and down the chain of command to an individual pillbox container. We use a serial bus structure to control the instructions and two-way communication throughout the entire assembled system. Our next building block is a cage that holds 4 modules. We fondly call it a 4-pack. A backplane on the 4-pack cage allows easy connection of the module through a connector and guide assembly on the back of the module to avoid alignment problems in the connection. We then assemble 3 4-pack cages to make a drawer assembly. Each drawer holds 12 modules, and the maximum configuration is 3 full drawers holding 36 modules and 360 individual pill containers. Once a complete system is installed at a nursing facility and loaded with the designated medications, refill orders are automatically generated and sent to the pharmacy using a secure internet access portal at the pharmacy. A printed fill order is the vehicle to fill the requirement at the pharmacy, and then a label is printed for the pill container when the shipment is prepared. Upon receipt of the refill container at the nursing facility, it is logged into the system, which then instructs the user to place the container in a random available slot, which the computer selects from the open and available slots on the facility's medication cart. The array of solenoids on the module control access to each pill container, and microswitches sense their presence or absence. The solenoids control a latching device that both locks to prevent access to a pillbox unless it is released by the system software, and blocks the entrance of a pillbox if it is returned to an incorrect position. We use this principle during our 100% functional test of each of the modules we produce using our system test software to speed the test procedure. Some medications will not fit into a standard container, so we developed a double-sized container that can accept the larger medications. These double containers take up 2 slots and are not symmetrical like the standard size pill container. We had to prevent the double wide from either going into the wrong 2 slots or putting them in backwards. The system knows which 2 slots the container belongs. Our hardware design prevents the container from going into the wrong place. The touchscreen system interface has secure access with password protection, and during the procedure of administering a medication to a patient, the combination of patient name, drug to administer, and physician must match the database, or the system will prevent the release of the drug from the system-locked pillboxes. Once the data is successfully entered, the drawer location is identified on the screen, and when the proper drawer is opened, the light clearly identifies the released container. All the other containers are locked in place. An additional feature of the system software includes a complete range of available reports at the pharmacy, who might control a drug bank of well over 100 carts. Reports are also available at the cart level for on-screen review by supervisor level access or for auditing by an appropriate enforcement agency. Our system is uniquely designed for this specific application and meets or exceeds the needs of our customer. It is tested during our manufacturing process at each level from component to module to 4-pack group. Then it is again tested after the entire cart has been assembled at our customer's factory before it is placed in service. The use of standard remote control software gives the ability to control the entire system for troubleshooting and debugging. Software updates are released online from the server-based software, and the system runs on Windows with custom application software installed in the onboard computer. Our company is extremely proud of the work we've accomplished in this fast-track, solidly designed and reliable product. Thank you for your attention.